So before jumping to any of the other concept, I will start with few of the basic commands. And in between these basic commands, I'm going to ask all the questions which may be asked in the interview. Okay. So the first command I want to start is this is the first command we always execute in Terraform. Okay. So whenever we are started, after I am done writing my code, this is the first command I execute called Terraform init. Can any one of you want to speak about this Terraform init command? How does it work? What happens under the hood? How does it? Okay, let's start with a simple one. Can anyone wants to speak about what exactly the work or the task of this Terraform init command?
This Terraform init command, creates a working directory with, and it automatically downloads the required plugins and all, I believe.
Yeah, absolutely correct. Yeah, thanks, Asif. So rather than me trying to tell you like what exactly the use of this Terraform init command, let's try to execute it. So this is a simple code that I have wrote. And here, what I'm doing is over here is that I'm specifying a provider that we have just discussed that Terraform support multiple provider. I specify out the region, which is US East 1. Here, I'm creating an AWS instance or EC2 instance. This is something, a reference, which we can utilize in our code. We are going to talk more about it. And one of you who works on AWS, we know that we need to specify the AMI and the instance type. Okay, AMI is called Amazon Machine Image. So it's the operating system image which we are going to use to boot our operating system. And this is a type of a EC2 instance. Okay. Now coming back to our original question, the first command we need to execute is called Terraform init. Okay. And like Asif has mentioned, it's go to this Terraform registry here. Let's go over here. And depending upon what we have defined it over here. So in this case, it's Azure. It's going to download the plugin from this HashiCorp AWS. Okay, the one which we have seen it over here, this HashiCorp AWS, and it's download inside our local directory. Anyone know where exactly is that local directory where it is downloaded all these plugins? So it's initializing, finding latest, installing this. Where exactly it is installing this local plugin? If I run ls over here, I only see the main.tf file. So this plugin is not here. So where exactly is this plugin is present now? Okay. If you run ls-al, you will see a directory called .terraform now. And this is the location. If you go like this, provider registry, you will see that it has downloaded something with a version called 5.13.1. Okay. So this is the location where it downloaded the plugin. So basically, when I said that Terraform is going to make a API call on behalf of us for this specific provider, basically it is going to consult this plugin inside this directory. And using this plugin, it is going to make those API call. And using this plugin means if it need to understand what exactly the AWS instance is, right? It need to understand what exactly the use of AMI and all those. That is defined inside those plugins. And using that, it is going to create the infrastructure for us. Okay, so this is the main idea behind the plugin. But in production environment, we normally do not define plugin like this. Okay, so if you go here and if you look at this, like for example, this I have gone from this providers AWS, there's something called a use provider. And if you look at that, there is something called this version is equal to 5.13.1, the one which we have downloaded. So basically, in case of production environment, or anyone of you who's using Terraform in production, we basically write a block like this. And this is the way which how I am following. I always create a separate file called terraform.tf and specify like this. So I will be 100% sure that next time, if I am or some of my team members who is going to execute the Terraform init command, they always will get this 5.13.1 version. Okay, so plugin is always being the same, right? And there's one thing which is missing from this documentation. The one more thing which I always prefer is specify something called a required version. So let me tell you what exactly is that. It's called required version flag, and it will take a parameter like this. Okay. Before I explain about this, anyone know what exactly I'm trying to do it over here? This is a required version, but for what? This is, you understand, like this is specific to plugin, that the plugin which we are downloading from HashiCorp. What, uh, anyone know what exactly I'm defining it over here like this? Okay, so this is the version of Terraform. So yes, Asif, I'm restricting the version of Terraform also. So I always want to ensure that for this particular case, my Terraform version will always be between this and this. So if you guys remember that from 0.11, anyone who is using Terraform from the earlier days, there was a lot of changes between 0.11 and 0.12. And some of us thought about like why they are even calling it 0.12. That should be called Terraform 1 dot something. So I can specify it like if any one of my team, let's remove this part just to make it simple, just to make sure that anyone who is going to use this code always have a Terraform version 1.2 or greater than that. Or even I will be more specific like this. It always need to be 1.2.0. If any one of my team member is trying to create a code or try to run this code, a version other than this code is going to be failed. Okay. So generally in production environment, we used to enforce this kind of a thing, that it must need to be on the specific version. At least I am following this kind of a best practice. I always want to ensure that my Terraform version is same and the plugin version should be same. Any one of my team member or anyone in the company who's going to use this code. Okay. So just try to follow this best practice. It's always going to help you. You will not see any surprises. Okay. Now coming back to the other part, if any one of you who looks at the output of this Terraform init command, you see that, okay, this is fine. We understood that part that, okay, it downloaded the plugin inside this .terraform directory. Everything is fine. There is one specific file that is created called terraform.log.sci. And this is one of the interview question. What is the use of this terraform.log.sci file? And anyone know what is the significance of this file, terraform.log.sci? No, not locking the state file, but something else. I know. I mean, these are something under the hood stuff, which most of the people don't think about it on a day-to-day basis, but these are something good to know things. And these are the questions they may ask you during the interview. Okay. So before that, let's look at this file. So see this thing. Basically, it's the same thing. Here also, they are specifying this something called a version. And the version is the plugin version. So most of the case, you do not need to worry about it. But out of the blue, if you're trying to do like or let me put it this way, in most of the cases, whenever the HashiCorp upgrade the version of plugin, they make sure that they have the backward compatibility. So let's say today it's Terraform 1.5, tomorrow it's 1.6 or something other version. And at the same time, they are going to upgrade the version of plugins also. Okay. So out of the blue, if somebody try to run this code from, let's say, Terraform 0.11, so this file is going to check, okay, we have this version over specified over here. And this, the version, I mean, that if you try to execute that code, that is going to fail. So this is nothing to do with the state. but something to do with this plugin version and everything. Okay. If that part is clear, we can move to our second question. Any question so far regarding whatever we have discussed?
So, yeah, Prashant, just two, three things. First is I would like to ask that can we check from using it like Terraform init command or any other command that instead of going to the registry.terraform.com every time, that what is the current version or what are the available versions so that we can modify our terraform.tf file according by checking that list or that we want this version, or do we need to every time revisit the official provider?
So, Kamal, the way I I used to do it is that always test it in pre-prod environment. That whatever the latest version. So the code, if I'm trying to go with some new version, I test it. So to answer your question, I don't think so there is any way to test it out. I always refer to the Terraform registry, see what is the latest version, and then move
Mhm.
backward.
Right.
And obviously test all the code in pre-prod and then only push it to production.
Okay. Okay. And so, and also does the main.tf, because while we will execute in a Terraform init, so I think the main.tf code will get executed if I'm not wrong. Yeah?
Paint.tf has nothing to do with the execution of your code. It only have to do with this provider, AWS. So depending upon whatever you have defined in this block, it is going to download the plugin depending upon your provider. If you do not provide this block also, it will check for this resource, like the resource name is starting from what. And the, I mean, the first thing has always been this one. If not, it is going to check the resource and see if AWS is define it over here. It will try to download a plugin for AWS.
Right. So under the hood, basically when we will execute the Terraform init, so it will just look for this main.tf, the configure provider configuration or resource configuration in main.tf, and accordingly download the provider, download the plugin on the local directory for us.
Exactly. And that is going to, if you do not hard code the value of like plugin like this, I mean the specific plugin name, it always download the latest plugin.
Okay, and in the main.tf also, I don't like I don't see there and is any reference of terraform.tf that which it has to use. So how does it automatically pick it up the terraform.tf configurations?
Okay, so let me go here. So basically how the Terraform init works, it check for all the file which ends .tf. Okay, and it is going to execute the code based on that. Now, how the dependency works, I'm going to discuss that in the next section. So basically, to answer your question, simply just look for any file which ends with .tf. In some of the cases, I have seen that some of the people, they define this code itself in this main.tf. And I think it's a bad idea because in future, in case if I need to upgrade this version, let's say 5.3.2, I need to come to this main.tf file and I don't want to touch this file. So I always follow this practice that I always have a separate file depending upon my requirement.
Okay, absolutely. Thank you. And in case, for example, there is a typo. Like for example, in case of terraform.tf, we mistakenly put terraform1.tf. So in case that won't work here, right? Because still it's a TF file. Right? So I think will init reject that file in that case?
Yeah, and I have a few specific command for those checking these kind of typo.
Okay. Okay.
Especially
Thanks.
this one.
Sure.
Yeah. Thanks, Kamal, for this great question. I will come to the dependency part right now, but before that, I just want to go for the second command, which is called Terraform plan. Okay. Again, I pause here for a second, and this is the one of the most important command. So after generally, if you look at the workflow of Terraform, honestly, we usually go with those three commands: Terraform init, Terraform plan, Terraform apply. Even this init we runs one, and then we go with Terraform plan and Terraform apply. Okay, so if you if this is the first time you are if you are learning Terraform, the key takeaway from this webinar or this session is at least understand these two commands. This will be really helpful for you guys. Okay, do anyone wants to speak about or type about or chat about like what exactly the use of this Terraform plan command?
It will show the like plan of like what all the resources that is going to create and create and what we define in the configurations.
Exactly, Shiva. Thanks. Yeah. So basically, the way I thought of like what exactly the Terraform command is, it's a dry run option. It is not going to create any infrastructure for you, but it is going to tell you what exactly it is going to. If you run something called a Terraform apply, what exactly your Terraform plan, what exactly this Terraform apply is going to do, reading this main.tf file, this is just going to display it on the screen. Okay. So before we move further, let's execute this and then we will come back to some of its other things. So Terraform plan. Okay. Required. Oh, I put that. So let's remove that because I created this with some other version. And okay, this guy. So basically, if you look at this, this does not create any resources for us. Basically, it is just going to display, like if you're aware of like git diff command, it is just going to display. And the most important thing is always look for this output. Please. Always look if it's doing something add or change, and more specifically, if it's destroying anything. That's the most critical one, right? So it is just going to display to the screen what exactly, if you're going to run the Terraform apply to create the infrastructure, what exactly it is going to happen. Okay. Now let's look something under the hood, what exactly this Terraform Terraform plan command is doing. So we understand that it is just a dry run option, which is going to do display everything to your screen, right? And this is, I think, a good security check to see what is exactly going to happen before executing any command. Okay. So like I mentioned, in case of Terraform init command, it is going to read all the TF file, right? So whatever the TF file you have created on that particular directory, it is going to read all that TF file. Okay. And it is going to create something special for you now. Not now, when we are going to execute something called Terraform apply, which is called a state file. Now I've introduced a new concept called state file. And state file is the way how Terraform knows that what infrastructure you have created. Okay, so basically these are called Terraform.tf state file. So what do I mean by that? So basically, if you look at over here, we have created this resource, or we are going to create this resource using this AMI and T2 microdot. Let's say in future, I want to create a resource using T2.medium. So how does Terraform is going to track it out, like what exactly I'm doing with this code? So the way Terraform is going to track it out, and we are going to see it, in next few seconds or minute, that it is going to create this Terraform.tf state file. And in this Terraform.tf state file, it is going to track all the changes. Okay. Now, you need to remember that when Terraform plan is executing, it is doing a bunch of things. So the first thing it is doing, it is obviously it's reading all your .tf file, which is present in the directory. It is reading all the state files. Okay. And like I mentioned, if you change this to something else, for example, T2.medium, you will see an option called refreshing state. Okay. Anyone know what exactly the refreshing state? Anyone of you who executed Terraform plan command, you must see this output called refreshing state. What exactly is this refreshing state? And so far we have understand like this TF, this is stored in my disk from where I am executing the command. State file, also it is stored on disk. We are going to see it in next few minutes. This refreshing state, what is the use of this refreshing state?
Change state in .tf state file after creating. Like it will modify the .tf state file. Is that correct?
No, it will never do any modification to .tf, just to be sure. Okay. So basically, like in this example, let's say we have created this resource using t2.micro, right? And now we are changing it to t2.medium. So that means there's definitely a change in .tf file. Like in this case, it's main.tf. Because we haven't run the Terraform apply, state file is out. State file has no information about it, right? And refreshing state means it is. This is one confusion which people completely misunderstood. That is Terraform plan is a network operation or not? Many people thought that okay, this is just going to read these two files which is present on the disk. No, it is actually going to contact our cloud provider. In this case, AWS. And in AWS, it sees that, okay, this instance has been created with t2.micro. And that state, it is going to store in its memory. It is not going to write into a disk. So when it is need to create a new resources and it is need to make a decision, it will take all these things into consideration. So for example, in this case, and that we are going to see, if I'm going to change this T2 micro to T2.medium, basically what I'm trying to tell it to the Terraform that, okay, destroy the earlier instance and create a new one with T2.medium because I don't need something with T2.micro. In case, if I need to create I need to keep this instance and I need to create something with T2.medium, what exactly I need to do is copy this block, put something different over here, and then I can create it. This is super important. Many people did that mistake, and that's why I emphasize on that point that whenever you are running Terraform plan, please look at this output, that you are not destroying any resources. I tell it to my team members or anyone, like, please, before applying it, always look at this output. Because Terraform plan is going to tell you what exactly your apply is going to do. So plan is really critical. Okay. Any questions so far?
Yeah, Prashant, just like to know that does the HCL language has any indentation restrictions as well?
No, but we can enforce this, and that I'm going to talk Kamal in next few seconds. Okay. It's not going to fade your code, but there are ways you can make, you can force it to fail your code if there's an indentation issue. So we are done it so far. And now I can tell you how people use this Terraform plan in production. So if you go to Terraform plan --L, there's an option called out, right? What you can do with this out, Terraform plan --out equal to, and you can give any. Okay. So basically it is going to create a file called tfapp.tfplan, and that file you can pass it to the Terraform apply. Now, why we are doing that? So if you look at this file, this is a zip archive file. So that means you cannot open it, right? It's a zip file. So if you try to do this, it is all binary file. Okay. The main reason behind that, and that is one other interview question, that because you can think of it, and I mean, it's just a thing which is enforced by security, that in case between Terraform plan and Terraform apply, if someone is going to do any changes to your resources, okay, so we always want to make sure that the plan that I'm applying is always the one which I have wanted. Okay, that's a very rare case that you have executed a plan, and between this Terraform plan and Terraform apply, somebody has made a changes. And it might be a possibility if you are working in a environment where lot and developers they are working on that particular code. So the only way I want to ensure that the plan that I'm applying or creating is always the one that I want to apply is by outputting the output of plan into a specific file. And what this command is going to do, it is still going to show you, display you all this into a screen. But at the end, it will say that this is the command you need to execute after this. Terraform apply app.tf plan. Okay, so basically you will pass this file and this is going to execute the command for you. Okay, I mean, this is going to execute the plan for you, sorry. Now, anyone know there's one big limitation of Terraform plan, and that is what it always been said that you cannot completely rely on the output of Terraform plan. What is that one big limitation? And that can only be solved by the Terraform apply. So Terraform plan is saying like everything is okay. You can use this AMI, you can use this t2.micro instance type to create an instance. But, and again, this is a hypothetical scenario, but there's always a possibility. With T2 micro, it's not going to happen, but with other instance type, there may be a possibility. Let's say AWS completely run out of T2.micro instance type. So plan has no way to verify it, right? Looking at the output, you will say, okay, definitely I will go with the Terraform apply, and that is going to create the instance for me. But Terraform plan has no way to check, okay, at the AWS end, will I have those resources available or not? Even Terraform apply does not have any way, but it is trying to execute that command and it will try to create it. And at that time, if AWS is having some resource limit, then it is going to fail. But just looking at the plan output and you will say, okay, you will be able to successfully create the particular resource. That is not going to happen. So you always need to run the Terraform apply after that, just to see if AWS has a sufficient capacity or something like if you are hitting some API rate limit. So let's say in a particular region, you can only create 50 T2 micro instances. But if you are trying to create the 51st one, plan will not going to tell you. Only when you're going to run the apply stage, that apply will going to tell you. Okay, yes, that is clear. I mean, this is really important to understand. Now the next command, like I mentioned, now we have this plan output here. We are going to execute the Terraform apply. And it is going to create the resource for us. We can go to the AWS, go to instance, and you will see it is creating that instance for us. Okay. And Terraform apply is going to work the same way like Terraform plan is doing it. In this case, we are giving him the output of the plan that we have created and passing it to the Terraform apply. So under the hood, it is, if we are not doing that, it is going to do the same thing. It is going to read all the TF file. It is going to read the state file. It is going to read the refreshing state from contacting the AWS, and then it from the Terraform apply. Right? So here it has been created. But let me tell you one thing. If you're just going to run this Terraform apply, in this case, we haven't changed anything, so nothing is going to happen. But see, we have this something called refreshing state. It is always going to check it if there's any change between the current infrastructure versus the one which we are trying to create. Now let's try to change it. Yes. Asif, that's what I want to show you next. Like I mentioned, let's try to change this to t2.medium, right? And this time, let's again start with Terraform plan. And like Asif has mentioned, this time we are not going to supply this file. So first, let's try the Terraform plan command. And this time, I want to ensure you that this Terraform plan command is going to contact the remote server. So see, it sees that, okay, refreshing state, and it finds some differences. So earlier we have this T2 micro, but now we are saying, okay, go with this T2.medium. And ID of this instance is 2232E. So this is the one. So see, that's what I always said. Please, please, please look at this 0 to add, 1 to change, and 0 to destroy. Okay. If it is trying to do something funky, please stop at that point. Now, rather than passing that out file, let's try to run the Terraform apply. See, Terraform apply again is the combination of Terraform plan and applying the changes. So it to tell you again, okay, it do one change and the drawback of that you will not see the output. It's just going to apply those changes. See, when we the plan command, then we are direct output. But if you are going to Terraform, you will see that you are going to see. So what in those cases? So now we are running the Terraform apply, and it is asking for that whether I want to perform these changes or not. So see here, do you want to perform these actions? Terraform will perform the action described above. Only yes will accept to approve. So type yes. Okay. So it's modifying the instance. But if you look at here, this is scary, right? Because it is actually stopping the instance. And then it is applying the modification. So that's why these output, to read this output is really critical. Because think of it, if you apply to some of the production instance, this will bring a downtime. Okay. So basically, what exactly it is trying to do, it is going to keep the same instance ID, but it is just switching from T2 micro to T2.medium. But at the same time, there will be a downtime because this is nothing to do with Terraform specific, but in AWS, if you want to switch from one instance family to another, the only way you can do it is to stop the instance, do the modification, and then boot it up. So same thing Terraform is doing it for you. Just again, a contrast, if you are using the earlier version of Terraform, what earlier version, this I'm using, I think Terraform version. I'm using 1.4.4. If you're looking for the earlier version of Terraform, what they used to do is stop the instance, delete it, and then recreate a new instance. But in newer version, they have provided this functionality where they are doing the change rather than destroying the instance. But again, I'm re-emphasizing that point. It is going to stop the instance. So please be careful about that. Okay. Any questions so far regarding Terraform init, Terraform plan, and Terraform apply? If you understand these commands, you learn half of the Terraform. Obviously, you need to learn how to write the Terraform code, but that is the main gist of the Terraform. I'm going to show you one option. I will not recommend to do that, but someone asked me on a LinkedIn, so that's why I want to show you. But please, really careful again about it. And that's the first option called auto approve. So if you remember the last time when I ran this output called Terraform apply, I need to put something called yes, right? And I'm going to show you with the help of one pipeline how this whole thing works behind the scene. But in case if you think that, okay, you are 100% sure that the output which is going to production or to any other environment is completely pristine, that is what you want to create the resources like this, then you can use Terraform apply with this option called auto approve. So when you pass this option called auto approve, Terraform is not going to ask you for that yes or no. It is going to auto approve it automatically. It is similar to like if you are aware of that yum, you always do yum y -install and whatever the package you want to install. So in that case, Yum will not prompt you to ask you, okay, do you want to proceed or not? Similarly, if you do this -auto approve, Terraform will automatically approve your changes. Okay, but again, this is really scary, and I mean, please be extra cautious before adding this option to your configuration. Okay, and at the end of this, I will show you how we are using this in like a real-time scenario, like how we deal with this kind of a situation. Now, one question I think which Kamal has asked me, how the dependency resolution happens in case of Terraform. So let me show you one code. Or I don't want to confuse you guys, so let me show you this one, network.tf. Okay. I mean, you don't need to worry about this right now at this stage, but let me put it anywhere. Okay. This is a simple code where I'm creating a AWS VPC, right? And then I'm creating an internet gateway. I'm attaching that internet gateway to the AWS VPC. Okay. If you look at here, I am just calling that VPC ID over here because I need to attach this internet gateway to this VPC, right? Now, how does Terraform create all these resources? So let's take a step backward. If you think, if Terraform is trying to create these resources in parallel, like for example, it creates in one thread, it is creating VPC, and in another thread, it is creating an internet gateway. Then this is going to fail because internet gateway depend upon this VPC ID, right? So VPC need to be created first, and then only the internet gateway need to be created, right? So anyone know how Terraform is working behind the scene to make sure that resources will always be created in that order? That, okay, it always need to create VPC, and then only it need to create that internet gateway. You got my point, right? How Terraform is doing that dependency resolution? Anyone has any idea? So to understand that, you need to understand something called, let me show you with a simple example here. Let's remove this one for the timing. So there's a command called Terraform graph. Let me put this into a dot format because that is the one which is supported by Terraform. And then we need to do something funky to create, to get the graph.png out of it, to get it in the PNG format. So under the hood, Terraform is creating this graph, okay, and all this cyclic dependency. So Terraform under the hood is aware that, okay, it first need to create a VPC, and then only it need to proceed to creation of this internet gateway. So Terraform is smart enough. If you are aware of the earlier version of Terraform, there is something called a depends on. Depends on, where we can specify the dependency. So if I do like this, I can write that depends on, and I will say, okay, this depend on AWS VPC dot app, which means this code is only going to execute once this code creation or the once VPC creation is done, because you understand that part, right? Because there is no point of creating the internet gateway and attaching it to the VPC if the VPC itself is not present. So we can use this depend on to fix that cyclic dependency. But honestly, in the newer version of this Terraform, I am not using this depend on at all. At least I haven't used it for last 1 year. Terraform is smart enough to build those kind of a graph. I can show you one complex one also, if it's there. Oh, graph.png. See, this is the one which I was playing it yesterday. And this is a quite complicated one. So see, Terraform under the hood is aware of like where exactly each thing is going. Okay, it know, for example, to create a load balancer, we first need to have a subnet in the VPC. So it has the idea about it. And similarly, to create a listener for load balancer, it knows that the load balancer need to be present. So it is under the hood, it is really smart enough to know this resource need to be created first. And if those resources does not have any dependency, Terraform is just going to create everything in parallel. Okay. So this will answer one of the questions I think Kamal you have asked, like how Terraform fixing all these dependency issue. So simple answer, Terraform is smart enough to know, okay, if this does not have any dependency, just create it in parallel. If it is a dependency, just wait for that resource to be created first, and then it is going to create the other resource. Any questions so far regarding this dependency or any of the command that we have run it so far?
Prashant, so in your Terraform file, you added the variable or the attribute depends on. So is that the only way it knows of the dependency between resources, or like in your in this initial version, you didn't have the depends on flag, right? So does it already know that it depends on the VPC?
Yeah, that's what I'm said. In the earlier version of Terraform, I used to use this depend on flag, not anymore. So Terraform internally knows that this resource depend upon the other resource. It is pretty smart enough on that. And how does it know? It knows through the provider plugin.
Okay, so it's not detecting the dependency based on your VPC ID line where it preferences back to the VPC ID.
I mean, if you need to explicitly define the depends upon, you can do it. I see some of my code during the code review, they rejected it because I used that depends on flag. So people really don't like this depend upon flag. So they need to rely on Terraform native functionality to figure out all these. If Terraform is not able to figure it out, okay, this need to be created first and then this need to be created, then only in those edge cases you need to use depends on flag. Otherwise, don't use it at all.
Okay, and what's the reason? Is it just a personal reference that they don't want to use the depends on, or it might cause some other issues that?
Yeah, so this is just for historical reference that in earlier version of Terraform, Terraform was not smart enough to figure out these dependency. But like I mentioned, like all the newer version, they are able to figure out all these dependency. So you don't need to use that flag anymore.
Okay, thank you.
Sure.
And just one quick question from the code. I think I asked one previously about the indentation. I think that's where we are going to cover later.
Yeah.
So, like in the first block, I'm saying the resource block. So in the first parameter, like CIDR block. So we after the assignment operator, so there is a key value, right? So left side of the assignment, right side of the assignment operator, and we don't have any kind of other symbol like comma to differentiate to let Terraform know that okay we are going to define the next parameter with enable DNS host names, right? So it will automatically detect that.
That we are going to see. I'm going to create some mess up and then we will see like if Terraform is able to detect it or not. So just wait for a few more minutes and we will work on that. I mean, I'm going to show you.
Sure. Okay.
So before going to that question, Kamal, I just want to show you one more command, and that command is a dangerous one, and that is called Terraform destroy. And as you can think it of what exactly this command is going to do, whatever we have created it so far, it is just going to destroy it. But again, the important thing is before it's going to destroy it, it's going to ask us whether you want to perform this action or not. You will see here. Do you really want to destroy all the resources? So basically all the, if you remember the plan output, it was showing everything in like plus, right? It is creating all the resources for you, but it is completely opposite now. It is all minus. And once again, please look at this output here. It is clearly saying it is trying to destroy one resources. Okay. So it is doing completely opposite of what we have done it so far. As you know that destroy, it's going to destroy our resources. So I need this instance for some testing right now, which I want to show you. So I'm not going to destroy it. but it's completely opposite. And the important part about it, which we haven't spoken so far, that it is going to clean up the Terraform TF state. So let's see that Terraform TF state file also. See, this is how the Terraform TF state file look like. If you look at any of the HashiCorp documentation, they clearly said, don't touch this file at all. This is something internal which Terraform is going to deal it with. And please do not modify any of the configuration. I will show you a few of the commands through which you can modify it, but please don't execute those commands. So say this is, if you look at the first value, it's called version. So this is something, nothing to do with the Terraform version or your plugin version. This is something whenever you are doing any changes to your Terraform code, it is going to increment that number. For example, if you're running the plan command, apply command, all those commands, it is going to update this version also. Sorry, not plan command, apply command. It is going to tell you the Terraform version which you are running. All the other thing which we can talk about it, but the most important is that lineage. Lineage is the way where it will map it to the version. So Terraform internally know, okay, for this particular version, I have this. I mean, think of it like a hash code for Terraform to identify the particular version. And then whatever we are doing it is going to tell us all this information. Okay, whatever you have seen in the output of the plan command. Now I'm going to show you few commands, but please don't run it in production or any other environment, which is called Terraform state. And Terraform state is a way to interact with the Terraform state file, which we have just seen. And because in the Terraform state file, we only have one entry, which is the AWS instance that we have created, right? So far, we are only creating this AWS instance. So you see only one entry. If I need to see that entry, what exactly it is doing, I have this command called Terraform state show. And this will give you all the information. Okay. So basically, you don't need to read that file, get that information. There is way that you can directly show that information. Now, few other commands which I want to show you, but again, please do not run it if you don't know what you are doing, is called RM command. If you want to delete that particular resource from your Terraform state file, you can even delete it. So let's say I want to delete this AWS instance one, which we have just seen. You can delete that. You can even move that one. So I want to move that to something called, let's say, demo. So this will directly update your Terraform state file and update that. But again, if you think from the AWS point of view, your AWS has some different configuration. I mean, your configuration file, this one, it is still pointing to Nginx, right? And now you have moved the state to demo. So next time when you're going to execute it, Terraform is going to create a new resource for you, because state file does not have that information. You have on the same time, if you update this to a demo, then this will be perfectly fine. But now, because there is a mismatch in state file versus what you have present in the configuration, this is going to create a conflict. So once again, please don't run this command if you don't know what you are doing, this Terraform state and everything. There are a bunch of internal commands which I haven't spoken about, and I'm planning to write a blog about it today. So there are something called import. So what import command is going to do is, like, if you have the existing resources in Terraform, existing resources in AWS, which you want to bring into the Terraform, that you can do with the help of import command. Honestly, in like last 5 years, I'm working with Terraform. I just work in one of the project where we try to bring all the resources which is created by CloudFormation to Terraform. And this is like a really painful experience. But anyone who is following Terraform, you know that now Terraform has something called import block. This is starting from Terraform 1.5. But still, it is not fully fleshed. Now you can specify this to block and whatever which is in present. So just to give you an example, let's say I have this instance that we have created, and this instance is created by, let's say I created this instance manually, right? So what I can do is I can copy this guy, this ID, put it inside the ID field. Now, whatever this I want to give it to the Terraform. Like, let's say in this block, I want to give it like AWS underscore instance Nginx. I can specify it over here. And then there's a command. Hopefully they have shown it over here to generate. If it's not, I can give it to you guys. So basically, Terraform is going to read this file and going to generate the corresponding this configuration file for you. So it is getting little better, but still you see that you need to define all these information manually, or you should have some kind of a code which is going to identify it, add this value, and then you will create the state file out of it, right? So this is a way to bring all the resources which is not being created by Terraform to your Terraform configuration. But like I mentioned, I only worked on this in one project, and that was a really painful project. It's getting better, but it is not there. Okay, there are other commands which I have worked like rarely. There's called a taint command. So taint command is also a way where you can mark a resource, and the next time when Terraform is going to see it, it is going to delete that resource and it is going to recreate it again. So for a specific resource out of the n number of resources. But I think we are digressing from the main topic. Just want to tell you, like, there are other commands which is available, but please use it cautiously. Most of the time, we always stick to the basic Terraform command like this: init, plan, and apply. And in some cases, destroy if you want to destroy your Terraform. Okay. Now let's go to the other command, which is called Terraform FMT. And anyone who is aware of Go programming language, you know that Go also has the Go FMT. And Terraform borrowed this concept from Go, because Terraform is written in Go, right? So they have borrowed this concept from Go, and this is called a Terraform FFT command. So this is called Terraform format. And the question which Kamal is asking me, and I keep on dodging it. So let's come back to that. So what exactly the use of this Terraform FFT command? So let's say I do not specify this proper indentation, right? I put it like this. So what this Terraform FMT command is going to do, Terraform FMT, it's going to format the file. So now if you look to the code, it is back over here. So basically, if I want to, like for example, in Python, we have the PEP8 standard, right? Similarly, if I want to format or lint a file before it is being pushed to the repo, that is the way we can do it. And I'm going to show you with the help of one pipeline how we are doing it in the production format. So basically, it is a formatting, but I can tell you few of the options which you can use it. So if you go to this help, right, there are a bunch of options. So if you look at the above output, it did not tell me like, okay, it formatted the file, but it did not tell me what exactly it's format. So let me tell you with the help of example that again, this time let's indent this one. And rather than using a Terraform format like this, I can pass the option called diff. Now it will tell me, okay, it is formatting this file, but at the same time, what exactly it is formatting, right? There is a space between this. And Terraform really don't care about if there's a space or anything. So let me show you. See, it runs out successfully. And the reason for that, Terraform is not a full-fledged language, right? It's just a declarative kind of a language. So if you add like 10 spaces here, it really don't care. But it looks bad from our point of view, right? We want our code, which is being pushed to some directory, to be properly indented. So that's why. Now I can tell you a few more things, which is really important. Like you see that when I ran this command, even this diff command, it showed me the output, right? But at the same time, it formatted the output also. It showed me what's the issue is, but it fixed the main file also, right? You see, it is back to the proper place. This, I don't want to do it in the production environment. And the reason for that, yes, Terraform is doing the right thing. It is able to format the output, it is showing me diff and all those things. But the developer who pushed the code, that changes is not being reflected in my GitHub or whatever repository I'm using, right? It's only in the Terraform local memory where it is doing all these changes, or wherever I'm running the CI/CD system. So what exactly we try to do in the production environment, we have this -- check, or something called right equal to false. What this is going to do, if there is an issue with the Terraform file, and we are going to see this practically, if there is an issue with the Terraform file, just fail the pipeline at this point. So what exactly I mean by that? I want a properly formatted code to be goes into my production environment. Okay, this is nothing to do with like with is it going to make any difference to my code or difference to my infrastructure? But I want a properly formatted code to be there in my GitHub repository as well as in the Terraform pipeline. So we always put this right equal to false, so that if anyone is trying to push a code which is not properly formatted, it will fail at the pipeline level itself. Okay, and I'm keep on using the pipeline because I'm 100% sure that none of you who is pushing the code in production is pushing it from your laptop or desktop. There should be a proper pipeline through which it will go through all these stages, and then only it will be pushed to production. Right? So in the last 5 minutes, I'm going to show you one of the pipeline examples. Now there's one more command which I want to show you. It's called Terraform validate. So let's say I did a typo mistake. Rather than instance underscore type, I put ty, something like that. If you run this command, it will throw an error. An argument-based instance type is not expected here. Do you mean instance type? Any one of you who use this command, do you know how this command works? Like where exactly it is taking, and how does it know that, okay, this need to be instance type rather than instance ty or any other thing? Or let me fix this. Let me put this guy. Okay, now I forget to add the quotes at the end, right? If I run this command, again, it is going to throw me an error like, okay, there's some issue with the code. Anyone have any idea from where exactly this command is checking all these things?
Via the log.html?
No. So inside this Terraform. So you remember, like when we ran that Terraform init command, it downloaded a specific plugin, and plugin has all the information about that particular provider, in this case, AWS. So if you are going to remove this, let's say, or let me move that Terraform to, let's say, Terraform underscore PKP, whatever it is. If I run this command now, oh, why it is still working? And this should fail. Okay, let me try to remove this. I don't know why it's working. And let me try to remove this Terraform underscore. It's still working. Okay, I have read the Terraform documentation, and there they have said that this will depend upon the plugin, and that plugin is going to check where exactly is all the syntax is, but somehow it is working. So I will cross check this. I don't want to give you misinformation, but okay, this is something weird to me. But the gist of it, you guys understand, right? Basically all these check, it is Terraform validate is going to validate it for you. So now I fix that issue, and Terraform validate will say the configuration is valid. Okay, so basically a validation step before you run the Terraform plan or Terraform apply. And if something failed at the validation stage, it's going to fail. Okay. Again, Terraform validate is not a foolproof. It's not going to check on the AWS side again if we have the sufficient T2 micro or something like that. It's just going to check your local configuration. And if that local configuration looks good, it is good to go. It does not guarantee anything. It's just to check all the syntax before you proceed to the next step. So just remember about that. Okay. Guys, please remember at least these commands to go forward. I think you guys should be aware of all these commands: init, plan, apply, destroy, format, and validate. I mean, these are the commands which we used to use, at least these 3 or 4 commands which we used to use in our day-to-day work.